Okay, so the last couple of sections are not necessarily specific to the quadratic form that we've been talking about in the last section or even earlier in this unit when we were factoring. We're going to talk about some other types of equations that will show up. And we still might see some of the methods that we talked about, like factoring, using kind of that grouping method, especially when you start to get these equations that have more than just 3 terms. So if we don't just have an x squared, or maybe we still do, but instead of it having like x squared plus x and a number, there's 4 terms that we have to work with, and then we're kind of stuck with having to do factoring by grouping. Other things that we'll talk about today is how to work with things that have radicals in them, so those square root signs. If we have rational exponents, so that would be exponents that are fractions, an absolute value, and we'll even still talk a little bit about the linear equation too in the next couple of sections. So when we were talking about factoring, we've seen a couple of different cases of when you need to factor this way versus doing it this way. For example, when we had 2 terms, so that could be anything like x squared minus 25, or we even have problems that said like x to the third plus 8. Those were the difference of squares and we also had like the difference or the sum of cubes. And we talked about like special rules with that. If you have the difference of 2 squares, like the x squared minus 25, you square root both of the numbers, the x squared and the 25. So x and 5 gets put into each set of parentheses, but one gets a plus sign, one gets a minus sign. That was kind of like a special property. Now the difference or the sum of cubes works kind of similar, but we had like specific rules for those, and they were a little bit longer, where you had to like cube root both of your terms, and then sometimes you had plus signs or minus signs depending on which rule you were using. So we've talked about those again in the past. 3 terms, if you had something like the ax squared plus bx plus c that we've been kind of working with the last couple of days, we talked about we could factor that. We could complete the square. Or we could use the quadratic formula. We could also graph, but we haven't really gotten too far into graphing yet. We talked about like vertex form with graphing and just using transformations, but we really haven't gotten down into the details of graphing quadratics yet. But we've talked a lot about factoring, and then last week we talked about completing the square and quadratic formula. When you have 4 terms, really the only option we have in order to solve these is to group them. And 4 terms could still have a quadratic term. You could still have an x squared, but maybe you have a cubed or something raised to the 4th power instead. So if you start to get to like larger exponents, we don't necessarily have factoring for all of those cases. So that's when we have to start using our grouping method. We try to put things together and then look for GCF. For example, if we look at this first one, right now it says 2x to the third plus 3x squared equals 8x plus 12. The first thing that we need to do, the first step, is we need to set this equation equal to 0. We talked a little bit about that with the quadratic. Anytime you're trying to factor something that's in a quadratic form, you want it to say equals 0. So we need to do the same thing for this one if we're going to try to factor it. So what I'm going to do is move the 8x and the 12 over to the other side. So I'm just drawing arrows to kind of show that, but I'm going to subtract both of those to the left side. And I'm going to rewrite this now so it'll say 2x to the third plus 3x squared, and then minus 8x and minus 12. Then we're going to try to group. So we're going to group the first 2 together and the second 2 together. What can we take out of the first grouping? X squared. And what's left over if you take out an x squared? Okay, what do we want to take out of the second set? -4, so we're left with... Good, remember we still want the parentheses to be matching. That kind of lets you know that you're on the right track. So even though we're using grouping now, we still want to make sure that those parts match each other. Okay, then we take the pieces that are sitting out front, so the x squared and the minus 4, and those come down to its own set. And then the 2x plus 3, that comes down on its own as well. The only other thing that I would want you to maybe do on this problem is I would want you to recognize that x squared minus 4 could actually be factored down a little bit more, because it is one of those difference of squares problems. I can square root the x and I can square root the 4. So I'm going to think about if I draw 2 more sets of parentheses here, each one would get an x. And what's the square root of 4? 2. So each one gets a 2. And remember I said earlier, each one gets a plus sign, one gets a minus sign. And then that 2x plus 3 still just needs to come down. We can't really do anything else with that. And remember, all of this, even from the very beginning when we move those terms over, is all set equal to 0. So if they're asking me to solve, I need to now set all of my parentheses equal to 0. What are we going to get for answers? Good. Now, truthfully, back on this step here, before we factored that x squared minus 4, you could have just solved that for x if they were looking for the answers, because you're going to add 4 and then square root it, and you get that plus or minus 2. We've done that before as well. All right, if we go into the next piece here, we're going to start talking about equations when they're underneath a radical sign. So this is when you're going to have a square root sign, or it could even be more than a square root. It doesn't have to just be a square root. It could be a cubed root sign, a fourth root sign, whatever. But what we're going to do first is try to get the square root to go away. Like, we want to just try to eliminate that to make this problem a little bit easier. Again, if we need to, we might need to move terms around just so we could get the radical by itself. So don't think about setting these equal to 0, but more think about, I want everything underneath the square root on one side, and I want everything that's not under a square root sign on the other side of the equal sign. So you kind of want to separate the two terms. And then in order to get rid of the radical, especially if it's just like a regular square root, you're going to square both sides of the equation. If it was like the third power, like a cubed root or a fourth root, then you would raise it to the third power or to the fourth power to get those roots to go away. So if you look at this first one here, we've got the square root of x minus 5, and that's equal to the square root of x plus 1 and then plus 3. I want to try to get rid of these square root signs. Since they're just regular square root signs, I'm going to go ahead and just square both sides of my equation. So I'm going to put parentheses around the left side and square it. And I'm going to do that on the right side too. Notice how I'm putting parentheses around the entire thing on the right side. So that squared is going to go to the radical and it's going to go to the 3. So on the left-hand side, remember when we square a square root, they cancel each other off. And so this x minus 5 is just going to pop out. Okay, now this quantity here is not quite as easy to deal with. So I'm going to break this apart over here. So I'm going to write this as 2 terms because I'm taking that entire quantity times itself. So I have the square root of x plus 1 plus a 3. And then I have the exact same quantity again being multiplied. And I'm going to think about what happens here if I were to FOIL these things. Now they're kind of messy because we've got a lot of radicals and we've got one regular number. So I'm going to try to go through this a little slow here so you can kind of keep up with me. If I think about my first terms would be x plus 1 and x plus 1. Both of those are underneath the square root sign. If we had something just as simple as like the square root of 5 times the square root of 5, we've talked about in the past that the 5 just comes out. Because if you have 2 square root signs, it's basically the same thing as squaring it. And so it gets rid of that radical sign. So in this case, the x plus 1 is just going to come out. That's for my first terms. Now for my outside terms, that would be the first square root of x plus 1, and it would be the 3 on the very end. I can't combine those though because one has a radical sign and one doesn't. So I'm going to have to just kind of stick them together. So I'm going to write plus. I'm going to put the number out front and then x plus 1. My inside terms, guys, are going to be the exact same thing because it's going to be this, not that, 3 and this x plus 1. So it's the same quantity again. So I'm just going to write out plus 3 square root of x plus 1. And then what would be my last terms? 3 and 3. So this 3 and this 3, which is 9. All right, let's see what we can put together here. So just on the right side, I just want to clean it up a little bit. I have an x, but I don't have any other regular x terms here, so I just have to bring that x down. This 1 can go with this 9 because they're both just plain numbers. So that becomes a 10. And then those pieces that are left are my square root pieces. Now, because they have matching radicals, that means I can add the numbers that are sitting in the front. So 3 plus 3 would be 6. And then that square root of x plus 1 is just sitting next to it there. Okay, now let's try to get terms over to the other side. So what's going to happen if I try to do this here? If I try to subtract this x, what happens? Cancels out on both sides. If I subtract the 10 over here, what happens? Negative 15. So I have negative 15 equals this 6 times the square root of x plus 1. I want to get rid of that 6. So I'm going to divide it by 6 on both sides here. Now, I can't really take 15 divided by 6, but can I reduce it at all? By 3s. And so it'd be negative 5 over 2. And now I have that radical isolated. Now that I have the radical by itself, I'm going to actually square this again. I know we did that at the very beginning, but I still have this radical kind of hanging around. So I'm going to square everything one more time. So if I square a fraction like that, you have to square the top and the bottom. So this is going to become 25 over 4, and it is positive now because anytime you multiply a negative times a negative, you get positive. And then this equals an x plus 1. What's the last thing I should do? Minus the 1. I'm running out of room. But I would take 25 over 4. I would subtract 1. And again, you have a calculator if you need to do that with your fractions. What do you get for a final answer? Good, 21 over 4. Okay, let's do one more of these together with those radicals. This one I don't think is going to be as intense as that last one because I see a square root of x plus 3, but on the other side, there's no square root. There's just the single one. So what I'm actually going to do first is I want to move this 3 over here. I want to get the regular pieces away from the radical piece. So I've got the square root of x plus 3 left. And then equals, I'm going to rewrite this now as x minus 3 because I'm subtracting that 3 over. Okay, now what I want to do is square both sides so that I can get rid of the square root sign. So what happens on the left? Cancels out, and I just have x plus 3. Now be careful on the right side. This is really x minus 3 times x minus 3. So if you FOIL that, what does it say? Good? So x plus 3, if I just clean up the right side, That becomes a minus 6x in the middle. What should we do now? I don't think I want to subtract the 9, only because I kind of like to keep the x squared where it is right now because it's positive. So I would subtract the 3 from the 9. What else could we move over? The x. We're going to subtract the x from the negative 6x. That's going to get rid of both of those terms on the left. I'm going to drop down the x squared. This becomes now negative 7x, and then 9 plus a negative 3 is 6 equals 0. Can we factor this? Can you think of two numbers that multiply to 6 and add to negative 7? Negative 6 and negative 1. So I would write this as x minus 1, x minus 6. If I set them equal to 0, what are my potential answers here? 1 and 6. Okay. Up above those, see how it says right here, don't forget to check your answer. Okay, so what that means is we need to kind of think about what happens if I were to plug these numbers in to the radical sign and like in for my x's up above. Do they work out or do they not work out? Because sometimes you get solutions, but just like we talked about on your quiz, sometimes you get solutions, but if it doesn't actually work out when you go to plug it back in, you have to throw it out. It's not good. So in this case, if I plug in a 6, let's start there. If I plug in a 6 back up here to the original problem, it would be square root of 6 plus 3 plus 3 equals 6. I'm just plugging in 6 for all my x's. What's 6 plus 3? 9. So this becomes the square root of 9 plus 3 equals 6. What is the square root of 9? Does 3 plus 3 equal 6? Yes, that checks out. That means this answer is good. Okay, I like that one. Let's check the other one, though. 1 is going in for my x's now. I mean, can you tell already if it's going to work? What's 1 plus 3? What's the square root of 4? What's 2 plus 3? Not 1, right? No. So that's a no good answer. You have to throw it out. Can't keep it. That's why it's important that we check, okay? Because we want to make sure that we don't take anything that doesn't work. What time do we get out of here today? 54? Okay. Let's call it for today.